All right, so I'm Marlon Pierce. As I said, I'm joined by Suresh. We're uh, leading the Science Gateways Research Center here at Indiana University. And our topic, of course, is creating a developer pipeline by teaching Science Gateway technologies. So I'm going to try and give you today an overview of a class that we've been teaching. It's just started its third semester here at IU, and it's currently targeting graduate students at the School of Informatics and Computing. So you, again, probably know, or as I just introduced, we have a center here called the Center for Science Gateways Research Center, or Science Gateways Research Center, that we are partially funded by the NSF and other organizations to build out gateways, to provide support for people building gateways, through the Exceed program, through the Science Gateway Institute, to and also to do core development of the Apache Arvata software stack. So we have a good team, and we have professional software developers and scientists on the team and so forth to do all this. However, we also, like all of, or many of you know, in your own projects or at your own universities, we have a pipeline problem, and that we have to find ways of recruiting and retaining people to work on science gateways. And this is a tough problem because, we are like a little subset of a very large and active field in building out software as a service and platform as a service solutions. And there are companies that can pay a lot more money than I can pay, or that universities can pay. So we need to find a way for supplementing the core team members that we have with a developer community that will come in, get trained up on the technologies we use, learn how to build science gateways, make contributions to the projects we have, typically core development more than consulting, and then move on to better things. So that's our pipeline problem. Part of this is related to the fact that Bloomington, as much as we love it, is not the center of the universe. So, as I was saying earlier, if we live in a small college town or university town in southwestern Indiana. It's not Silicon Valley. It's not Brooklyn. How do we recruit people who want to come and build gateways and do exciting distributed systems research? When we can't, when we're not necessarily located in the best possible place and not able to pay the best possible salaries. So if only there was this untapped reservoir of talent close by that we could draw upon. This, for those of you not from Bloomington, this is Lake Monroe. So there is, in fact, an untapped reservoir of talent that we realized we needed to plug into, and that, of course, is Indiana University. So, there is a number of. So there's obviously a large number of students. There are hundreds of students enrolled in the School of Informatics and Computing. Can we identify the students there who are for whom science gateways are going to be interesting, for whom these things are going to resonate? So in effect, can we hire people who will work for Spotify, work for Facebook, work for Google, work for exciting startup companies? Can we do that? And the answer is yes, we can. We just have to get them as their students and hopefully give them an advantage in their own career searches by working for us and learning lots of interesting things in their own career path, so they can step up to those companies after they graduate. So again, our pipeline solution is recruit students to work with us by teaching a graduate level class on the underpinnings of science gateways. And this means for our own internal planning that we have to embrace change, or change in our team, frequent turnover. So we have stable development, and stable developers, and stable leadership, but we need a way to efficiently bring in lots of people, get them involved in building out or testing different parts of the gateway infrastructure we build, and making contributions and then moving on. So first thing you have to do, of course, is, and I say, we've also tried other mechanisms, or we've used other mechanisms in the past, such as Google Summer of Code, and going on the campus to recruit students and so forth, to tell them, hey, we're Science Gateway Center, Science Gateway Group, we're over here, or if you're interested, come talk to us, and so forth. And it's worked to some extent, but it's actually not worked as well at tapping into the local talent pool as we would have hoped. And so that's why we've been targeting a class. So the next thing is you have to say, when you're recruiting students, or whether you're offering a class, you have to tell students this is what you want to take. You have to make it interesting. So, the question is, we do an outreach seminar to the School of Informatics here, and we want to recruit a bunch of students and convince them to take the class. We have to say, what is a science gateway? Because they're not going to know. So a science gateway is a user-centric environment for conducting online computational science. That's not going to work. So these are not actual, they're not computer science students. So, that kind of approach, that kind of description of a science gateway is not going to be especially appealing to the students. They're not going to know really what we're talking about. We're going to have to introduce all those sorts of things more gently. So one approach we've been using is to put it this way and say, what if Mark Zuckerberg read more chemistry and biology books? So everybody knows Mark Zuckerberg. As I've said before, I was disappointed here to learn that the Three-Body Problem book is not actually a physics book. So if Mark was, instead of trying to build out Facebook and interested in social networks and things like that, if he was instead interested in how to build out a computational or a web-based environment for helping scientists conduct online experiments, and that would be what a gateway would be. Okay, so we got some attention. Right, Mark Zuckerberg, Facebook for scientists. Okay, kind of, I think I might get that. So then we have to dive a little deeper and say, what are the goals of this class? What are you going to get out of this for the students? So goal number one is, as you can read here, apply basic distributed computing concepts to science gateways. So one of the our insights here is that let's say our insight, but one of the general things that lots of us have observed is that there's been an inversion over the last 10 years in where all the research and innovation in distributed systems or to a large extent is happening. It's not necessarily at universities anymore. It's going to be happening at Google. It's going to be happening at Amazon and so forth. And so we have to recognize that, and we also want to attract students who want to make careers in that field by saying science gateways are going to make use of they're going to make use of that fabric, and they're even going to allow you to understand how that fabric itself works. So, one of the touch points for the class is that a lot of the problems a lot of the foundations of globally scalable cloud computing were worked out decades ago, and we're sitting around gathering dust in computer science and other journals before suddenly exploding. Everybody realizing, oh my gosh, this stuff is really important. It really is. We're really at the point where we have systems that need to pay attention to all these problems. Fault tolerance, for example. So that's one of the goals. One of the goals of our teaching in this class is to not just turn people loose on to Amazon or OpenStack or something like that, but say, spend some time looking at the core distributed computing concepts that underlie a lot of those systems. Goal number 2 is apply new architectures, methodologies, and technologies to science gateways. So microservices and DevOps are a couple of buzzwords for ways of building software as a service and platform as a service systems. So Netflix, for example, famously pioneered a lot of the microservice architecture, and this is a picture of the Chaos Monkey, part of their army that is used to randomly take down services and see how resilient their system is. So we want to say, so what we're doing in the class and recruiting students and later in teaching them is saying gateways can be built out of microservices, and likewise, gateways are going to need to know to build microservices and to build gateways as examples of software as a service. You're going to need to know things like how to do continuous integration and deployment, which is one of the underpinnings of DevOps. Is there a question?
No, there's no question so far.
Okay, great. So just to expand upon that a little bit, a decade or more ago, I was using my time at a supercomputing conference wisely by working on a proposal, and I drew the figure that looks something like the one in the middle here, which was jokingly referred to by one of my colleagues ever after as Marlon's octopus diagram. But this was how we were building out a gateway at the time, about the same time that Mark Zuckerberg was a freshman at Harvard, I guess. Maybe a little say at the same time. So part of our goal in teaching this class, and this has evolved over a couple of semesters, is that Mark Zuckerberg and Facebook don't look like Mark never looked like that. Facebook doesn't look like this. So why should gateways keep looking like this? Can we rethink gateways? Can we rethink gateways to use more modern approaches and more modern architectural styles? In part because it'll be useful for ourselves, and also in part because we want to attract students who are going to want to work in that kind of space and who are going to be interested in these sorts of approaches as part of their career development. So, and then the last goal that we teach them is open source practices. So as many of you know, Suresh and I and others on our team are proponents of Apache Software Foundation mechanisms and governance models for running open source projects. And part of our selling point here is that students, as they're working in the class, they're doing everything in the open. They're following open source projects, or open source methodologies. They're filing issues. They're making sure all their Git commits are associated with descriptions and discussing their problems and so forth. So it's basically, you should think of your course code repositories as being in part living resumes that you can then use as as the students are looking for internships and jobs and so forth. So in short, the challenges for science gateways, which I list here, are also all relevant for anyone who is interested in developing software as a service solutions. If you want, in many cases, these are grad students, these are international students. They don't have any specific ties to Indiana or Bloomington. This is a way stop for them on their way to hopefully working in on one of the U.S. coast for highly innovative companies. In the process of their education, they can learn about all of these different aspects of science gateways, which are going to be applicable to their later jobs. And I'll also say a lot of the students that we have are coming back to school after a few years in software development, and they're not here to come to school for a couple of years and then go be software developers again, but are more interested in how can they take it to the next level and become more system architects for software solutions. So I think one of the things that we found in the class, in teaching it the way we do, is that students, they can all program, of course, but this is for many of them the first chance to really think about things as mundane as how to structure their Git repositories. It's all been told to them before, or how to, here's your deployment pipeline. They may have used continuous integration before, but they didn't set it up. They didn't design it. Now they have a chance to do all that stuff. So happiness. So we've had, again, we taught the class since spring 2016. So our first class was just started just over a year ago. We had 13 students in the first class, which we in part wanted to be a little bit small. So as we figured things out ourselves. And then fall of this year, fall 2016, we had a larger class of 36 students. And then we're teaching another class this semester, mostly composed of students from the previous two classes on some more advanced topics. So I'll say possibly a little bit more of that. So but now I want to give you a little bit of a taste of what it is we actually teach in the class. So as I'll also point out on my last slide, we have all of our slides, course material, and so forth posted at courses.arvata.org. Some of the details of particular project assignments sometimes in order to we use the IU Canvas system, so we have a little bit of a split. So we want to usually tell the students the definitive assignments they'll find in the Canvas system, because that's where I'll be doing the grading. So if your university is using Canvas, you can also, in addition to the courses.arvata.org, you can also get access to our Canvas material.
You're asking to speak louder.
Okay.
Will be speaking.
Okay. So is the sound getting better?
I can hear you fine. So I don't know. It might be local to the person who needs extra sound. Yeah. Someone else also said their audio is fine. So maybe it's their computer. Sometimes headphones make the sound quality better than if you use your computer speakers.
Okay. Yeah. And again, we're recording these, or Catherine's recording these, so we should have hopefully the audio on that will be good, and you can go back and check that out later. All right. So what do we teach? We did actually teach students a little bit about cluster computing, how to log in, how to run jobs. So this is actually a description of or architecture diagram, if you will, for Blue Waters, but it's also a pretty good general overview of lots of traditional cluster systems. But that's not really what we wanted to spend most of our time on. So especially as we iterate the class, this actually turned out to be a little bit of a distraction for where we got lost in details such as was the description for how to run the code correct, and things like that, which weren't really, they're important for real gateways, but they weren't necessarily where we wanted the students to spend most of their time. So what we did instead, as I've said earlier, is especially in our second go around, is say this is a class in large part about building microservices and for science applications, but for building microservices and tying them all together. So first assignments are not to submit jobs. First assignments are to build out a collection of mock gateway microservices. So this is one of the underpinnings of the class. So you kind of actually learn this going from the first class we taught to the second class we taught, which was, don't teach them too much about that octopus diagram because they'll all build it, and a lot of them will want to use things like Spring Framework and whatever. That will make it very difficult to decouple it later. So instead, tell them to start fresh. We're building mock services. We're not going to worry yet about how to actually run a job on a supercomputer. We're going to mock all that up, but we're going to do our best to get the architecture right. Next thing we teach, of course, is microservices play well with containers like container technologies like Docker and other ways of doing virtualization and other ways of doing our Linux containers. So, your microservices aren't all going to be directly accessed by client applications. You're going to go through an API server. And so a large part of or a significant assignment in the class is to pick your API technology and use that to design a good API and good data models. So a couple of technologies or approaches we had the students look into. One is Apache Thrift, which some of you know that we use pretty extensively within the Arvata project. And then also we teach the students how to all about RESTful APIs. Hopefully, and not just doing REST RPC, but also learning things like HateOAS approaches and how to use Swagger and things like that.
Marlon, a quick question came in.
Uh-huh.
Gary Gorbett asked, are services mostly on the gateway side or mostly at the clusters?
Yeah, these are all services that are running in the middleware. So these are all gateway side services. So we don't, we're not running services on the clusters themselves or the computing clusters themselves. A little bit more I could say about that, but yeah, Gary's familiar with our software a little bit. So yeah, we could think of these microservices are different parts of Arvata, or they map to different parts of Arvata.
He says thanks. Oh, yeah.
Okay, the next thing is messaging systems. So the microservices themselves need to communicate with each other. You can do that in lots of different ways, including RPC calls or REST calls or thrift calls. But you can also use, once you are building up these microservices step by step, you also can see the advantages of using messaging approaches like like RabbitMQ or Apache Kafka, which are a little bit different systems, but I'll push them together in one heading. So there, the students use this in part as they learn how to do things like make their microservices fault tolerant and how to do some load balancing and other things like that within their microservice clusters or microservice ecosystems. Next is resource management and scheduling. I said a little bit about Mesos earlier. It's useful in a couple of ways, and this is relevant back to one of Gary's questions. You can use Mesos to help manage the Docker containers that are running your microservices, among other things. It's really good for that. That's how it's probably used mostly in the real world. But you can also, so Mesos is a resource manager. It's analogous to Torque. And like Torque, you have extensions provided by different providers, such as Moab, the Moab scheduler, and things like that. So Mesos can take different schedulers. And one interesting thing about Mesos is you can actually have multiple schedulers working simultaneously as different tenants. In any case, Aurora is one of those types of schedulers that's kind of like a traditional job submission engine. So we found it actually useful in the second version of the class to we still wanted the students to get an idea that they had to run jobs on clusters, and they needed to build in this fault tolerant asynchronous set of concepts into their structure, where that some jobs are going to be handed off to things that wouldn't necessarily be under their full direct control as a gateway provider.
Gary is asking, isn't that on the cluster though?
Yeah. So it's both. So you can run Mesos as a way for, it's one way of keeping your microservice collection up and running, and that's in your middleware. So you think that, say, that runs on Amazon or on I use Jetstream or someplace like that. And then you can also use Mesos to run jobs on, you can use Mesos, for example, on top of Jetstream or on top of Amazon or so forth, to push through a bunch of simulation jobs. You can use it in both ways. So we give the students the opportunity to look at both of those. So Aurora is the scheduler that submits jobs, more or less. There's another plugin to Mesos called Kronos, and there's some others that can be used to make sure you have a certain number of your microservice instances up and running. And then another thing we teach is, I'll call it distributed state management. You might call it service discovery as well. And there's some other things you might say can be done by things like Apache Zookeeper and some more recent tools like Consul. So these are nice things for, if you have cooperating microservices and you need to keep track of them and also keep track of their state, the state of your executions as might be going through multiple microservices. You can do that with Zookeeper. And then, of course, security. So this is more at the, in the class so far, we've taught it more at the API level, but we'll also be in the future looking at it, how it applies more in the intercommunication, the security problems that occur in the intercommunications between microservices. But we give the students an assignment, among other things, where they're going to OAuth 2 and OpenID Connect enable their gateways. And then lastly, got to pull it all together. And so teach continuous integration and deployment. When I say we teach, what I mean is we give assignments that require, for successful completion, the students to have an end-to-end system that can be easily graded. And so the general motivation here is, or the spur is that whoever's grading the assignment, whether it's a TA or it's Suresh or it's me, should be able to go to your Git repository, look at any instruction should be in the wiki, of course, for your Git repo. But in order to grade your assignment, all I should have to do is on the correct branches associated with that assignment, make a trivial edit to a README file or something like that, which should trigger an entire execution chain where you go from the code being pulled over to your continuous integration system. We usually use Travis CI in the class. We've also used Apache Jenkins, and then get deployed onto your deployment environment, which we typically have used Amazon Code Deploy for doing that. But we always encourage students, we can make recommendations and say, these are, you have to do this. It has to be buildable someplace by a simple Git commit that I can use as a trigger. But if you have good alternatives, if you want to explore different approaches, you don't have to necessarily use what we recommend. So anyways, this is baked into the class, especially with the as we refine the class. So you of course have to have a build system among other things, but you have to make it as easy as possible for us to grade your whole assignment, so you don't have to thrash around trying to figure out how to get your code installed. So I think the response to this on the class has been generally good. There's some students or some teams who will sometimes have problems with this, but I think most of the student teams really embrace this. And I should step back and say the way we run the class is through project teams. So each assignment, and so the students will go through, they'll pick their own teams, usually between 3 and 4 students per team. And we warn them up front, they'll need to have a broad range of expertise. So for example, the microservices were required to be developed in at least 3 different programming languages. And also, because we're going to be doing some system level Unixy stuff with continuous integration and deployment, they're going to need somebody who's on their team who's either familiar with system administration, if you will, or else they're really interested in diving into that. So that's a lot of topics to cover in a semester-long class. And so what I usually preface a lot of my lectures with is that this is not a tutorial. So in case you don't know the French below it says this is not a pipe. So for some reason that picture is hanging in the room where we taught the first class a year ago. And so I use this to say the lectures are intended to give you high-level overviews. They're intended to provide you with the background, tell you why, but not really to tell you how. It's up to you as the student teams to solve the problems that we give you. So again, I'm not going to spend a lot of time in a class giving a tutorial about here's how to use Docker, but rather if I say you build out microservices, containers are something you should be looking at. There's Docker, there's Singularity, LXC, and so forth. It's then up to you to pick the technology as a student. to pick the technologies that you're going to be using and put them in place. So you learn by doing. So how well are we doing? So I won't speak for Suresh, who teaches about half of the class. My personal philosophy was formed about 30 years ago when I was a poor freshman in chemical engineering, and I was taking a Chemie 100 class at Louisiana Tech University, and the department chair was teaching it, and he said, the ideal engineering faculty is somebody who gives terrible lectures and impossible homework assignments. So, and he did fulfill at least half of that. He did give pretty bad lectures, and I became a physicist. But that's another story. So, how well are we doing? Now it's 30 years later. I'm the old guy in front of the room. If I'm using the same philosophy a little bit, it would be reflected in our evaluations. And so you see we have about half the students, a little bit less than half the students responded to the survey. So how effective was the class time? It was okay. How effective did out of class work help? Well, that we got a pretty good response on. Yeah, that's the out of class work is really helping learn. Some more responses. How likely are you to recommend this course and this instructor? Some pretty good response there. Again, this was taken from a sample of 36 total students, 36. I like this next one. How much did the instructor, you should think instructors here, Suresh and me, how well did we motivate you to do your best work? I hope I gave a bad grade to the person who said just a little bit. Not really. Okay, maybe they have other things, but yeah, I really was thrilled to see that we are in the class motivating students to do things, to work hard and do your best work. A couple of extra things. How much did the instructor emphasize student learning and development? Good response there. The students felt like we were helping them learn and develop. And then the next, I think the last one, last of these charts, compared to other classes you've taken, how much time did you spend on this course? And 7 out of 16 said much more time. Or 12 out of 16 said that they spent more time on this class than any other class. So the old Chemie department chair, wherever he is, hopefully is proud of me because I gave mediocre lectures personally. I won't speak again for Suresh, but we motivated them to work hard outside of the class and to learn on their own. And 2 more pieces of feedback. What did you like most about this course? I think that I like the one from the bottom. I'll draw your attention to. This course is like no other. Coursework introduced us to some really interesting concept tools and technologies in a practical, hands-on manner. I think students also, we gave them an opportunity to, besides these anonymous surveys, to give us some face-to-face feedback. And this was coming out a lot, is that there's no other class, like this that they were aware of in the department. What did we not do so well? As you may know by now, after listening to me for half an hour or so, I'm not the best lecturer in the world. I put a lot of effort into it, but still it's difficult, especially if you're using this is not a tutorial philosophy, to always give great lectures. But that wasn't necessarily my personal goal. It was not to make students leave the class thinking that they knew something, but rather leave the class thinking they better learn something because they're going to need it for the homework assignment. Sometimes we felt like we needed to introduce some topics and then give the students some more hints about how to do the homework. So motivate some of the lectures.
Marlon, there's a question that came in from Jack Smith as to whether, Suresh just answered it, but whether all or most of the students were computer science.
Yeah, they were all computer science. Actually, we initially, I had this, the first version of the class actually put into a wrong section from my own misunderstanding of school of informatics organizations. So, which attracted some data science students, but so that we quickly, Suresh quickly got our courses pushed out to the computer science mailing list, and we had almost complete turnover between the enrollment and the actual start of class. So yeah, these are all computer science, or almost all computer science. They're expected to program. They're expected to know how to build things, to use. They're expected to make some deep dives into some non-trivial and to complicated systems. So I don't know the backgrounds of all the other departments within the school here, but we really expected the students to be pretty firmly technical. But that said, anybody who wants to dive in can try it.
Yeah, and also there was a question on in science gateways, big data analytics are becoming important. Do we need to provide how to manage science data, etc.? So I think as you saw Marlon describing right from the early on, like the class has heavily focused on microservices and how to coordinate between microservices and so on. Like, we've been trying to keep the class at an architectural level. That's the whole point of why you need microservices, like evolving from the octopus diagram, what Marlon was showing, to the microservices is so that we could add these kind of capabilities to the gateway. So if you want to add, for example, data analytics capabilities, you will add in new microservices without disrupting existing HPC-based execution capabilities. So the way to do that, what are the kind of concepts we can borrow from this Facebook, Google, and Amazon-like infrastructures to do that is been kind of that focus there.
But yeah, I would say also, I didn't dive into a lot of this, but the classes are kind of split between introductory and advanced. So we have an advanced version of it going on this semester, and we have more introductory last semester. So I think we're really, in the introductory class, we're looking for students with whom all these topics really resonate, and they really like this stuff, and they're good at it. And then either through independent studies or through taking an advanced class or things like this, or we hire them. They can get involved in some of the other topics. But I think we're looking at this in part through a selfish lens, that we're trying to find the students who are going to be, we have, as I said, this is a talk about a pipeline problem, and we're looking for students who are going to be able to dive into Arvata and make contributions there. And so we don't want to bog them down, however, with giving them too much, if you will, background about everything that a science gateway can do, but rather try and abstract that out at a mock level and let them learn their skills, like just as with practicing your musical scales, if you will. Learn how to do that, and then we'll give them more complicated things after their 6-month orientation or their semester orientation. Right. So that's my last slide, or this is my last slide. So more information in the next steps. Again, you can see all the or most of the material that we have collected over the last 14 months at courses.arvata.org. If your university is using Canvas, you should be able to also find some of our define our Canvas class. If not, I'll try and see if I can get that published through Canvas correctly. And so in Canvas, you're going to find more details, again, as I was saying earlier, about the specific assignments that we gave the students. And we are interested in one way or the other in taking what we're doing here to a broader audience, either through helping you stand up your own version of a class like this, and sharing teaching materials and things like that, or else taking it to another level of which I haven't worked out the details yet with, but how we can actually offer these things as online courses if there's sufficient interest. And with that, I'll say thanks, and please ask some questions.
I'll point out there was a question in chat that Suresh answered, but that in case folks aren't following in the chat area, and I don't know if maybe if you or Suresh wants to talk through them. Jack Smith had asked about distributed data services as a topic, and Suresh had explained it was part of the advanced class, and that there would be a bouncing back and forth between a foundation class in the fall and then in spring recruiting selected students to do advanced topics. And then also Randy asked if there were no exams, was it all homework or project based? And Suresh answered that it is all project and class participation based.
Right. Yeah, and to build on Jack's question, if you have topics that you'd like to see covered, especially in advanced class, and that are gateway related, but also are motivated by real world applications or problems, then we'd love to hear from you.
Also, another question from Mona. She asked if she may have missed earlier, but are these undergrads or grad students?
Currently grad students, but we are interested to see if we can involve advanced undergraduates as well. That's something we haven't done yet, but we'll look into in fall of next year.
Do you think it's something that would be appropriate for undergrads?
I don't know. So it so we'll have to find out, I guess. And so part of it is that we don't necessarily require the students to do a super amount of code development so much as integration. And there is some coding involved, but there's also a lot more of integration of tools and solving of architectural problems and things like this. And so, the students we have now in the class are, as I was saying, for the most part, coming back to school after spending some years as programmers or something else related to that, and for real companies, and they're interested in making a quantum leap in their own career paths, being more architects than just programmers. So how well undergraduates are going to be able, I wouldn't know. I think we've seen in some participations in hackathons aimed at undergraduates that a lot of them are really, really good. And again, what we're trying to do is hire a bunch of people who would otherwise be working for Facebook or Spotify or whatever else, and just do that before they take those other jobs. So get a year or two out of collaborative work from them. And so, some really good undergraduates should be able, I think, to do some of the work we've done, or the work we assign, but we'll really have to be careful on that front.
Marlon, this is Nancy. Thanks for a really good talk this morning. This is really outstanding. I could see some universities being interested in such a thing. It sounds like you're making the complete curricula and all the materials public, which is great. You can correct me if I'm wrong about that. But you could see kind of a university maybe tailoring this for themselves where you have all the basic building blocks. And then when you get to specific projects, perhaps they could bring in gateway topics that are of interest locally and kind of going on, in a local setting. And then you get students to contribute to those projects and it all kind of hangs together in a nice way. I think that's maybe something that we could promote through the Institute. But yeah, very, very nice talk and nice job sharing, all the comments, good and bad.
Mm-hmm. Maybe I had another 3 or 4 pages of bad comments. You don't know. So actually, yeah, I didn't want to portray us as being, or myself anyway, as being the superstar lecturer. But just to follow up, all the material, as I was saying, it's online, or you're welcome to use it, and also we always welcome suggestions for improvement and other contributions, and like and to build on what Nancy was saying there also is that the class is not, we're not doing this because we want to help the next generation of software architects on their way. And, we have some self-interest in this, and it's to identify students who are for whom all this stuff really resonates, and they really like doing this stuff, and they really want to get involved more deeply in gateways. And so that's not going to be an order of tens, but it will be some number of students who can then get involved in gateway projects more directly. And so again, we look at this, we hope we're laying the foundation for a pipeline of students to come through the class and then work directly with our Gateway Center. And so you can imagine a similar type of thing happening in other places where you use this as a way for identifying the students with whom you want to work.
And there was one more question on would it be better to incorporate smaller scale projects into an existing software development classes? Not sure, we haven't thought in that angle, mainly because we had even trouble, in a couple of tries, how to scope this, in the sense that it took an entire semester for the students to build a good microservice architecture. So the trouble is we haven't seen, we are seeing in the university the lectures vary from the basic software engineering, basic programming to some basic specific cloud computing classes. We've kind of taken a different approach, very hands-on, and that hands-on required the entire semester. But that's an interesting idea, we have to think through what we can extract and bundle into existing classes, if that's possible, or if the faculty are willing to consider that.
Yeah, just I'll reiterate that I didn't really say this in the slides, but the class projects build on each other. And so, as Suresh was saying, you take the students go through the projects one at a time, adding something new to the, major new contributions at each step. So it wasn't really designed to be broken up and integrated into another class like that. But yeah, I mean that's given time and motivation, whatever. Of course, those are things that we could solve. But we like the idea of these classes, of having this arc in the class where the students start from nothing and wind up with a real cool, totally functioning system by the end of the class.
So one thing I can think of is maybe some specific function improvement of a gateway can be something like a project that may require integrating different kinds of tools.
Yeah.
That either is an Exceed gateway or the SVCI.
Yeah. And one thing I think, like, if you didn't catch it, like, think the class was entirely taught on Amazon, like, or primarily. In the first semester, we tried to use, like, the Exceed infrastructure plus and so on. In the last, like, 2 semesters, we've been focusing on Amazon. That's been a good learning for us too. And that was an interesting way also to bring in, like, to add to Sudhakar's point, like, one is to bring in Exceed, or the students, like, very well study Amazon and cloud infrastructure, like how to bring in those to the existing gateways will be also an interesting extension to look into. And then and the point about Amazon is it was a good excuse for us to look into, like, what if you want to build gateways, you want to solely build on infrastructure as services and build all the services for yourself, or on one hand look at the open source and what you get from open source, what you contribute to. This other angle is the services, like what kind of services, like Amazon or other cloud platform services, you want to layer over the gateways on, and so on. So that was, some of these were good. And also on the guest study in comment, yeah, I think, yeah, that having university IT team engage is a good idea. I think we tried to do that actually with from Jetstream administrators, OpenStack lectures from Red Hat, and so on. And generally that worked out good actually.
We did incorporate a fair number of guest lectures and so forth. And yeah, we didn't rely exclusively on Amazon, especially not during the first semester. But yeah, I mean, it's something that this again, the students were pretty interested in using, and we had to make these decisions, such as, after teaching, after introducing Docker and microservices and so forth, Amazon has an out-of-the-box solution, Elastic Container Service. So do we want the students to use that, or do we want them to use an open source tool themselves to coordinate their containers? And so we tend to veer towards that second approach, and give it at least a chance, probably the only time in their careers, to build a system and not just make use of services that they can get from the cloud fabric.
Well, Marlon, I think we've hit the top of the hour. Mm-hmm. So I want to thank you for presenting. As we mentioned, this will be available online, and also we hope everyone will click the link that's in the chat section for giving us 30 seconds of feedback. As you know, Marlon and Suresh like getting feedback on how well they've taught. So it gives you an opportunity to say what you think, and also let us know if there are other topics you'd like us to cover. So if also, if you have any questions for them, I'm sure they are happy to respond. You can find them both on our, I think both of you guys are listed on our website. If not, we will make sure that your email address is there for contacting. So I'm going to put that chat link again, just so you can quickly jump to our evaluation. So with that, I think we'll say goodbye.